Okay, so here we are again. For the honors students, we have another extension to the molecular formula. And so I'm on your homework number 8. And like I just mentioned in the last podcast, that question number 1, 2, and 3 are exactly what I showed you. So I'd like you to take a look at question number 4. Let me move this out of your way so you can actually see it. So um, hopefully you're in class on time. So we're question number 4, and it's going to be a combustion reaction. So you can see it contains only carbon, hydrogen, and oxygen. We don't know the formula of that. That's what we're trying to find. So it says that it's burning. All of you should probably know that in order to burn that we need oxygen gas. So we have carbon, we have hydrogen, and we have oxygen. And we don't know what amounts they are, but we do know that it's burning. And it says it yields carbon dioxide and water. So we have a certain amount of carbon dioxide plus water, but again, I can't balance the equation because I don't know what my original compound is. But I do know the amounts. So it tells us that we have 10.68 milligrams of this. I'm just going to divide that by 1,000 and get it into grams right off the bat. And carbon, same thing, I have 16.01 milligrams, and divide that by 1,000. And then I have 4.37 milligrams, divide that by 0.00437 to get that into grams, divided by 1,000. So what I want to do is I want to be able to take this carbon and hydrogen that's on the right-hand side and transfer back to figure out what my formula is. So if I take a look, you guys know percent composition. I think you would agree that I could find the percent carbon in carbon dioxide, I could find the percent hydrogen in water, and then subtract those two values from the compound that I started with to figure out the oxygen and then work on my molecular formula from there. So that's what I'm going to do. So I'm going to find hydrogen in water. So when I do that, I know that in my compound, I have 2 grams of hydrogen, the molar mass of that, over the total that we've done already is equal to 0.11. Now I could go ahead and multiply by 1,000 and say I have 11% hydrogen in water, but I don't really need to do anything more than this, so I'm just going to take that it's 11% or 0.11, multiply by the amount of water that I have, which is 0.00437 grams, and I'm going to say that there's 4.8 times 10 to the negative 4th grams of hydrogen in my compound. So I'm going to do the same thing. I'm going to find the amount of carbon in carbon dioxide. So when I take a look at this, I know that my mass of carbon is 12, and in carbon dioxide is 44, not 4.4, should be 44 grams per mole, and that's going to give me a percent of 27.3 or 0.273. Again, multiply by the mass of carbon dioxide that they said that we are able to produce, and that gives me 4.37 times 10 to the negative 3rd grams of carbon. Okay, so if I look at my original equation, you guys can see that I have carbon, hydrogen, and oxygen. So I'm going to subtract the amount of carbon and hydrogen that I just found, and then I can find the amount of oxygen. All right, so I know that I have 0.01068 grams in my compound, so that's what I started with. I'm going to subtract the 4.8 times 10 to the negative 4th grams of hydrogen, subtract 4.37 times 10 to the negative 3rd grams of carbon, and that's going to give me 5.8 times 10 to the negative 3rd grams of oxygen. Now I'm at my starting point that I'm just doing a regular empirical formula problem. So now I'm going to take the grams, divide them all by their molar masses, and then do my mole ratio. Okay, so we have to keep going. It's kind of a long problem. Okay, so to find the amount of hydrogen. So my hydrogen is going to be I started with 4.8 times 10 to the negative fourth grams divided by its molar mass. And I get 4.8 times 10 to the negative fourth moles. So I'm just converting to moles. Then my carbon, I figured out that I have 4.37 times 10 to the negative third grams of carbon divided by its molar mass. And 3.64 times 10 to the negative fourth moles. And I'm do the same thing for oxygen. I found that it's 5.8 times 10 to the negative third grams divided by its molar mass. 3.64 times 10 to the negative fourth moles. So here's the point where I divide by the lowest number of moles. And so here it's going to be 3.64 times 10 to the negative fourth, which is going to give me 1.3. Don't really like that number. Divide this by itself, and that is 1. Divide this by itself, and that is also 1. So hopefully you remember that because I have 0.3, I can't really say it's 1 or 1.5. How do I round that? So I'm going to multiply this by 3 to get it to a whole number, which is 4, times 3, which is 4, times 3, which is 3. Sorry, 1 times 3. I need to go back to kindergarten, or maybe second grade, whatever it is. Okay, so there I can say, there's my empirical formula. Now I get to do extend a page, and I'm sure you guys are not writing small enough. So if I take a look, I can see that I have 3 carbon, 4 hydrogen, and 3 oxygen. And this is my empirical formula. And if you recall, I need to find the molar mass of this right away, which is 88.0 grams per mole. Okay, so I just put in my ratios. I found it was 3 to 4 to 3, and I found my molar mass, which is 88.0. Now I'm going to go ahead and try to figure out what my ratio is. And in the formula, it tells us the molar mass of the compound is, here's my ratio, 176.1 grams per mole is the molar mass in the compound. I found my empirical formula is not the same, so my molecular is going to be different, and this equals 2. So I need to go through with my empirical formula and multiply everything by 2 to get my molecular. So it would be C3H4O3 times 2 is going to give you C6H8O6, which is going to equal my molecular formula. Whew. All right, so it only took me almost 8 minutes to talk through that one simple little problem, which isn't so simple. Hopefully the mathematicians in the room enjoy all of this. For the rest of us, you can do this too. It's just a little process, and the process is the same for every problem. So on the back side, you have questions 5, 6, and 7 that are exactly the same as what I just walked through. Good luck, and please bring any questions to class that you have. Have a wonderful night, you guys.